Hi, my name is Sebastian Palacino, and in this video, I'll be talking to you about what is Meltdown. So I'll put a presentation, just give me a moment so I can share screen, and we'll begin as soon as it's ready. Now we're going to share the screen. Okay, everything seems working, so here we go. What is Meltdown? Before we begin, I'd like to tell you that this presentation is based on the article Meltdown, Reading Kernel Memory from User Space. I put in this image the article, the name of it, and the authors, also at the universities they come from. So now that is clear, we'll be talking about the outline of the presentation. So first, we'll be talking about the introduction to Meltdown and the issues this presents. For understanding Meltdown, we need to talk about the key concepts, some key concepts that are vital for you to understand Meltdown. So that'll be the second point of the presentation. As soon as we get that, we'll go into the third point, that there will be Meltdown itself. We'll be talking about steps for Meltdown, what it's used for, and its building blocks, okay? And the fourth point, we'll be talking about the countermeasures to Meltdown. That is Kaiser. Kaiser is the countermeasure for solving Meltdown, or actually the best possible solution that has come so far. Finally, we'll be talking about the conclusions that the article presents and the conclusions that myself has learned in the article that I've read. So here we go. First, the introduction to Meltdown. You see, a vital feature of security system is memory isolation. Memory isolation is the cornerstone for multiple operating systems, and it allows our computing environments to run multiple applications at the same time on the personal devices or on the cloud itself. On modern processors, the isolation between the kernel and the user processes is typically realized by a supervisor bit of the processor that defines whether a memory page is accessible or not. So what Meltdown does is that gets the better of the memory isolation. It takes advantage of it. How does it do it? By two things. By exploitation of the side channels in major operating systems. Technically, Meltdown does not exploit any software vulnerability. It exploits side channel and the out-of-order executions that we'll be talking about in the following slideshows. Meltdown allows unprivileged process to read data mapped in the kernel address. So as you can see, it's a big issue that it needs to be talked about and it needs to be countermeasured. So the first key concept for understanding Meltdown is the out-of-order execution. Out-of-order execution is an optimization technique that allows maximizing execution units in the CPU. What does this mean? Well, the out-of-order execution executes as soon as all available resources are present. So a better way to understand it is the following image. This image is a simplified single core of an Intel Skylake microarchitecture. What you can see here is the microarchitecture of the Intel Skylake, but I want you to pay close attention to the second block, the execution engine. That is where the out-of-order execution happens. So the micro OPs are forwarded into the reorder buffer from the front end. Once they arrive in the reorder buffer, the reorder buffer is responsible for register allocation, register renaming, and retiring. The micro OPs are then sent to the scheduler. The scheduler will send them to each execution unit. The execution unit can vary from the ALU operations, the AGU operations, and or memory loads and stores. That all would depend. The second key concept that we must understand for Meltdown is the flush plus reload attacks. Flush plus reload are cache attacks that work on single cache line granularity. They take advantage by flushing a target memory using the CL flush instruction. What flush plus reload attack does is that it measures the time it takes to reload the data, and that way it determines if the data was loaded into the cache by another process in the meantime. So The third concept we must understand for Meltdown is transient instructions. The name itself explains actually quite well. However, transient instructions occur all the time, and they occur as the CPU runs ahead of instructions to minimize latency. This way we maximize performance. So, we'll be talking about Meltdown. First, we must talk about the building block for the attack. You see, Meltdown consists of two actually blocks. The first one, there will be the exception handling and or suppression, and the other that will be more about the transfer of the secret itself. So the first building block handles the exception handling or suppression. A transient instruction is sent into a microarchitectural state change. This way, the microarchitectural state change is transferred via covert channel into an architectural state into the second block. This way, a side effect happens and the process is leaked. That way we recover the secret, as you can see in this image. Okay, so now we're talking about the Meltdown, the steps to do it. Meltdown consists of 3 easy steps, actually. The first step is to choose a memory location which is inaccessible to the attacker. So this way we load this memory into a register. The second step to do it is to access a cache line based on the content of the register. This is done via a transient instruction. The third step is to do a flush plus reload attack to determine the access cache line and the secret in the memory location. This way we are able to see the memory, the secret that was in the memory. So what you can do with Meltdown? Well, with Meltdown you can do 4 things actually. You can read the secret, you can transmit the secret, you can receive the secret, and probably the most problematic issue with Meltdown that it is such an issue nowadays that you can dump the entire physical memory of the kernel. This is actually quite dangerous. So we need a solution for Meltdown. The solution is called Kaiser. Meltdown takes advantage of hardware vulnerability, not a software issue. So the best way to do it, you will think to be, is a hardware, but that is actually quite expensive to change the hardware. So you then might be thinking, well, Meltdown takes advantage of the out of order execution, so we can take that off. No, actually, you see, out of order executions really help the performance of the CPUs, and if you take it out of the equation, the performance of the CPU will take a serious hit. So what do? Well, the answer is a software patch that inadvertently protects against Meltdown. That is Kaiser. So what does Kaiser does? Well, Kaiser impedes the kernel to point to memory locations in the user space, impeding leakage of randomized offsets. And you might think, well, Kaiser is perfect. Let's all implement it and it will solve all problems with Meltdown. Yes and no. Despite protecting against Meltdown, Kaiser does have some limitations. Due to the design of the x86 architecture, several privileged memory locations are still required to be mapped in user space, and that leaves a residual attack to surface for Meltdown. So it's almost perfect, but not quite it. But it is the best available offer for solving the problem with Meltdown. So, what are the conclusions of this video? Well, we saw that Meltdown presents a real threat because of its exploitation of out-of-order executions and side channel attacks. It enables a user to read sensitive data of processes. So Meltdown is a big issue, really. So we must implement an effective countermeasure against Meltdown attacks, and that is Kaiser. Kaiser must be implemented in all major operating systems because Meltdown affects all of them, Linux, Mac, Windows. In the article, you can see that the effect on this major operating system varies depending on each, but there is a problem with the three big ones. So Kaiser must be implemented as soon as possible. So this was my video explaining Meltdown. Hopefully it's useful. Hopefully you managed to understand it. If not, I highly recommend you check the article. It's very helpful. They explain it very well. And well, I want to thank you for your patience and for watching me in this video. And I hope that Meltdown is clear for you as it's clear for me. So goodbye, and I thank you for your attention.